Hello, we're working on Chapter 4, Section 3, Writing Functions. I'm going to do the guided practice problems that are in the back of the section just before you do the homework. So these problems are very similar to what we've already covered with the examples, and very similar to what you're going to see on the homework and the assessments, the quizzes and the tests. All right, let's look at problem number 1, or excuse me, problem number 3. Problem number 1 and 2 are like fill in the blank questions, so usually I skip them just because they're vocabulary. Problem number 3. So I want to find the relationship that between each of the x's and the y that is paired up with it. So pick something easy. It doesn't matter. Whatever works for one should work for all of them. I'm going to do the 2 and the 0. So the options for this example would be subtract 2, because 2 subtract 2 is 0, or multiply by 0. Now in the previous video I had a problem that was very similar to this, and where one of the options was multiply by 0. And I didn't say it at the time. This is what happens when you do a problem like it again. But the reason why I went here where there was a 0 is because 0 is kind of a neat number. If your option was to multiply by 0, then all these would be zeros. Remember, whatever works for one pair has to work for every pair. The function works the same for every x, it works the same on every x to give whatever the y is. Got to think about how I say things. So since I don't have a whole bunch of zeros all the way through, which is what you would get if you multiplied by 0, that's not what the relationship is going to be. So let's look at the subtract 2. So if I did 2 subtract 2, I get 0. 3 subtract 2 is 1. That works. 4 subtract 2 is 2. And even over here, 1 subtract 2 does equal -1. So it looks like this one is what we're going to do. How do I write that as an expression? Well, I take my x, the letter that's standing for my input variable, and I just write -2. And that's going to result in my y. So y is given by taking x and subtracting 2. You can also write that in function notation, where I write f of x equals x subtract 2. But at this point, if you just use the y, that's okay also. All right? Moving on to problem number 4. So I go from 1 to 4, from 2 to 7, from 3 to 10, and from 4 to 13. All right, so let's pick the 1 to 4. It seems like I can either multiply by 4, or I can add 3. So let's see what works with this one, right? So let's try taking all the x's, 1, 2, 3, and 4, and multiplying by 4. So 1 times 4 is 4, that works. 2 times 4 is 8, not 7. I don't have to check the rest of them. I will, but I don't have to check the rest of them, because if it doesn't work here, it's not going to work. It's not the rule. It has to work for all of them. 3 times 4 is 12, and 4 times 4 is 16. So it only works here, not for here. So that's a no. Let's do add 3. 1 plus 3 is 4. 2 plus 3 is 5. It didn't work here. 3 plus 3 is 6. And 4 plus 3 is 7. So the adding 3 is also a no. So we have kind of a complicated one here, and it may take a little bit of figuring out in order to get this one done. So I'm going to help you with this. Don't panic too much about it. We're really going to explore these type of problems when we get to Chapter 5, outside of Chapter 4, the next one. Okay, so here's what I want you to look at for this one, all right? You know that the ones, we've got a pattern. So you got 1, 2, 3, 4. Might be easier if I make this into a table, like problem number 3, instead of a set of ordered pairs. And the y's are 4, 7, 10, 13. 4, 7, 10, 13. It doesn't look like either of these one-step methods are going to work. So here's what I'm going to try. How do I go from 4 to 7? Well, I could add 3. From 7 to 10, I'm going to add 3. And from 10 to 13, I'm going to add 3. So I notice that there's a rule here. But what I'm doing is I'm repeatedly adding 3 over and over again. If I continued it, my next one would be 5, 16. After that, it'd be 6, 19. I would keep adding 3 in the y's. Here's the tricky part, and again, this is more chapter 5, so don't panic about it. Repeated multiplication is that, excuse me, I got ahead of myself. Repeated addition is actually multiplication. That's what the whole times, the word when we say times, that's what it means. How many times are you adding 3? So I'm going to try this. I'm going to say, all right, what happens if y equals 3 times x? So let's look at this pattern here. If I did 1 times 3, I get 3. I'm going to put that right there. If I do 2 times 3, I get 6. 3 times 3 is 9, and 4 times 3 equals 12. That's not the y values that I have. So you might look at that and go, well, that didn't help. But it actually did. Because look, after I get to 3, I go to 4. After I get to 6, I go to 7. After I get to 9, I go to 10. After you multiply by 3, there's only one more step you have to do. Just add 1. So for these problems where you actually have 2 steps, usually you're going to multiply by something, and then you're going to add whatever you need to. What you multiply by is how much the y values increase or decrease, because it may go down also. So here's my 3 that it's going up by. That's what I'm going to multiply by. Remember, repeated addition means multiplication. And then check it. If I actually do that, what else do I have to add in order to make it work? Okay? So that one was a little bit difficult. Don't panic about it. We'll see you.